Ever wonder how a machine that just follows a list can actually make a choice? Let's dive in.
So that's the big question, right? How do these rigid machines pull off such flexible thinking?
To get how they make decisions, we first have to look at their default mode.
Think of it like reading a recipe. You just go from one step to the next in perfect order.
And the thing that keeps track is called the program counter. It just points to the next instruction.
After it does one thing, the program counter just adds one. That's it. It only knows how to move forward.
But just going in a straight line is, well, pretty limited. So how do we break out of that?
The answer? Special instructions that have one superpower. They tell the program counter to jump.
So instead of just taking the next step, the program can literally leap to a whole new part.
And that brings us to the real decision makers of the computer world: branch instructions.
You can think of these as two kinds of turns you might take at a fork in the road. First up, the unconditional branch. This one's a forced turn. No questions asked, you just jump.
But a conditional branch, well, it asks a question first, and it only jumps if the answer is yes.
All right, now let's talk about the instructions that let us pause and take a helpful little detour.
We're talking about subroutines. Think of them like little specialist programs you can call on for help.
A call instruction jumps to that specialist, but first, it carefully jots down where you left off. It saves that return address on a special to-do list called the stack. Then, when the subroutine's done, the return instruction checks that list to get back to work.
It grabs the last address off the stack, and boom, you're right back where you were, no problem.
So, this is all cool hardware stuff, but why does any of this actually matter to us?
Because every if statement, every loop, every single function call in your code is built on this.
So here's a quick recap of the tools that give software all of its power and flexibility.
Without that jump, a computer is just a calculator. This is what makes it a truly dynamic machine.